in the interest of not keeping us here longer than the 4 o'clock, it's already been a bit of a long day, I think, for some of us with so much new software and stuff. I'm going to focus now on something a little bit simpler. Now that we've understood a little bit about what is possible with Earth Engine and how we can get this data, the focus now for this last little piece is turning that into a nice visualization. So something that you would want to put into a report or put up on a website or something like this. We're going to use basically the same modules. A lot of it's going to be the same with how we download the data and get this time series. The next piece will be how do we make that into a nice looking figure? How do we make a figure that has a map and also a chart? And how can we run this consistently? So if we just change the date range, it makes a new figure. So that's the idea, that we want to be able to make this consistently and smoothly. So we can load in our modules and do this same test like usual. I'm still using this long tongue elevation. Of course, you can use whichever point you like. And I'm going to do basically the same thing I did before. This is getting the same rainfall time series. So this is not different from what we just did in the first half of last exercise. So we just get the rainfall data for Langtang. So all I want is my basic time series, and now we're going to start doing something more with it. This is what we were doing before, right? We just made a simple plot. And if somebody put this in a report, I'd say you got to tell me what these dates are, right? They're all overlapping. What is this axis? What is this axis? It's not so pretty, right? You wouldn't want to publish this, or somebody wouldn't want to pay money for this report if you gave it to them. Let's think about the different things we might want to do here. The first thing I always notice is when 0 is somewhere up floating in the middle of my chart. And also the front and the end are floating sort of in white space. So you can, for any chart that you make in Python, you can set these minimums and maximums to whatever you want. So you can set the y limits and set the minimum of 0, and you can set the x limits to be the first date and the last date. So this is going to be exactly to the length of our data. And if we run this, it already looks a bit better, right? We've spread things out a little bit. No data is floating around. It looks a little bit nicer. However, we are still missing some nice things like labels on our axes. And we could probably also make this font size a little bit bigger, depending on who you're going to send this to. So I added a couple more things here. So I'm adding an X label and a Y label. And I'm setting this font size to whatever I want. And I'm making it bold. And I'm also making my tick labels. So these labels, I'm making them a little bit bigger. And I'm also, I guess, rotating them so that they look a little bit nicer. They don't overlap so much. So with just a couple of lines, we can make something that looks a lot nicer already, right? This is much easier to read than that first thing of just jumbled labels. Let's add just a couple more things. We can also put just some dots on there so we can really see, was there more than one day that was raining a lot right next to each other? Like here, for example, or is it just one single day? So putting a little dot and putting a little legend so we know what this means, that can also help a lot. And then let's put the last thing on here, which is a title and some grid lines. Right? So this is something you might see in a report, right? This looks a lot nicer. And it's not particularly a lot more difficult, right? We just added a couple little pieces that make it much clearer to follow. And now that you have this little piece of code here, you can also just use this, right? You just put in your different climate data there and change your font size, change the axes labels to make sense for what you want. And this is already a much nicer figure that can go in a thesis or something like that. If we, let's, just for comparison, oh, my computer is getting slow. So that's what we started with, right? That's the same data, and that's how we end up. So even within Python, right, it's very possible to make quite nice graphics. You don't have to go to some fancy image software. You can do some quite nice plotting just in here. So that's what we can do with time series. But the other thing we started doing was maps, right? So we looked a little bit just here at the end at this. Let's bring this up again. I'm sure, how many of you have used QGIS before? A few? Okay. A few of you. So QGIS is a very nice software for working with geographic data that's also free. You can, of course, go in to any of the data sets and give them a color scale, but you can spend a lot of time just going in and changing the colors, and you still just end up with something like this, right? It doesn't have grid lines on it. It doesn't have a title. You have to spend a lot of time for each individual map that you make. So if you wanted to make one map for here and one map for here, you have to do this process over and over again. The nice thing about Python is when we're doing something like this, if we just change one or two letters here, if we want to say, okay, this is actually long-tongue rainfall sum, we can just quickly rerun it, and it will give us the same thing with the same format without us spending a lot of time moving labels around, right? So once you have it set up in a way that you like, you can just automate it. If you wanted to do this for 2021 instead of this, exactly the same process. You just change the data that goes in. So what I want to show you in the next few minutes,
How can we save that picture?
Save this picture. Very good question. So we have here this f. This is the figure, and you can just do f dot save fig, and you just give it a name. So let's say test image JPEG. And now I should have somewhere here test image. And I can just open this up. And you can, of course, do some extra things here, like let's make the DPI 300 and make sure that it doesn't clip off our edges. And we should now have a slightly nicer image, right? Yeah. Yeah, so this is also something that you can do over and over again, and you can just save it for each year, each month, however often you need to have these. But this is the case for time series, right? So far we've just made a lot of images of time series. But often you also want to make a map, and you don't always want to have to go through this, choosing your colors and changing it over and over again. Those of you who have done GIS stuff know that it can take a long time when you're trying to make these images. So it is also possible to make maps like this from QGIS or from Python. So that's what I want to show you for the next few minutes here. So what I'm running here, so we could leave this on here, I am again loading in my chirps data, so this rainfall data from all of 2023, and then I'm doing a sum. So I just want the annual 2023 rainfall sum. I'm again using my Trishuli outline, and then I'm exporting it. So this is my rainfall sum that's only going to be over Trishuli. And I should now in my Google Drive, or since I already downloaded it before, you can also, these are all on GitHub. I have this Chirps 2023 rainfall sum. If we just look at it, it's this tiny thing here. So it's a much higher resolution than this ERA data, right? So that's what we have from the ERA data, and that's what we have from Chirps. So I can quickly download this data, right? Which the next step then would be, how do I load that into Python? There's a few different ways to do that. I think the easiest one is this raster IO. This is one of the modules that I had you guys install. And you can just open our file and read the data, and you can use a plotting program or from this same matplotlib imshow, image show. So instead of plot.plot, plot image show. And this will take this grid data. So this is exactly what I just showed you here, except now I have it in Python. And since I have it in Python, I can add it to a map. I can put it side by side with my other maps. I can, make a nice color bar. I can do a lot of different things, and it will always be saved, right? I can set up a set of parameters that make sense for my area and do it over and over again for different time spans. So let's first, this is where this CartoPy module, this is where if some of you had trouble installing CartoPy, this is the little piece that you get to miss. CartoPy just gives us some extra data about projections, and they have things like a coastline. So if you want to make a map over a large area, or you want to have the coast, that's already in there. But we can also just plot, and I got to zoom out a little bit to show these maps. So I can make a plot in my projection. I can add borders in my dashed line, and then I can just plot my geographic data. Since I loaded my Trishuli outline as a geographic data from GeoPandas, it knows how to plot this directly on a map. So I can put this directly onto a Python map. We can also, on that same axis, we can do the same thing. We can also put our what am I putting on here? I'm putting on just some grid lines so we know where we are. And I'm adding my data here, right? So I put my imshow. That's that same thing. And I put my geographic data, this data that I just created from Earth Engine, directly on this figure. Of course, we're not so happy about having a big blue thing covering all of our rainfall data. So we have to play around with our colors a little bit. So I can change my colors for my Trishuli. And just slowly, each time I'm making my map a little bit nicer, right? But I'm not having to go back and readjust this. Once I've figured it out, then I have my final thing and I can use that forever. So I'm changing my outline here. Then we can put on a title. So in the same way, we can add a color bar and put on a title. And we start having something that looks a little bit more like something you might have in a report, right? So we have our color bar label that tells us our precipitation sum in millimeters. We know what we're looking at because we have a title. We know where we are because we have our geographic axis labels, also with some grid lines. And these are all little parameters that you can control on your own, right? You can change these if you want smaller or larger grid spacing. These are all things that you can change quite simply here in these little parameters. Yeah, anything else that you guys think that we could add to this map, or anything else that you guys think is missing from such a map? All right, then we'll leave it at that for now.
Also possible to add some set files of river line or some things.
Of course. So far I'm just adding here, I'm plotting my Trishuli outline, but you can do this for any shapefile. So if you have a geographic data of the rivers or something else, right? Lake outlines, whatever you want, you can plot those right on top. And in the same way here that I just changed this color, you can choose different colors for different ones. Yeah, it's very customizable. So maybe as a next step, or a nice way to put these together, if I again make my rainfall time series and I just combine this. So this top part, this is the map. This is exactly what I had just here. And the bottom part, this is that chart. So that's exactly what I copied from that nice chart that we made. And if I run both of them together, I can have something that looks like this. So here's my rainfall for just 2023, and here's my rainfall just for 2023 on a map. Right? And this is something that you could do for every year or every month, and you can just make a series of these just by changing one or two parameters. And it was very quick to download this data directly from Earth Engine, right? It took less than a minute to run some of these grids, and then 10 seconds to run this thing. So it's not a huge computation thing to run this once a week or once a month if you need some sort of consistent data that's updated. Or if you want to have a map on your website that is updated once a week and you just do it once and it changes the file. That's the idea for showing what's possible to do these kind of consistent maps in Python. To take it finally one step further to make it all the way automated. So there was still a step here where I had to go to my Google Drive and download something and then run something else, right? So every time that there's something that somebody has to do manually, it always doubles the time, right? Even if it only takes 10 seconds for the data to process, you still have to wait and download and move and all of this. So the idea is, since our Google Drive, this is something that you can link on your computer, right? I don't know if any of you use Google Drive as much as I do, but it is possible to access your Google Drive just like it's available on your computer, just like if you have Dropbox or something else like this. So when you create an image or create some new analysis and it's on your Google Drive, you can access it directly from this Python without going through downloading everything, which means that you can really quickly change your analysis and get a new image, and it can all be sort of seamless. So I'm going to do one more example with some sort of rapid data. So some of you talked about what kind of latency or like how long do we have to wait to get some of this data. And GPM data, this global precipitation mission data, it usually is up within 24 hours, sometimes less, closer to 12 hours. So this is one of the most rapid data sets that you can get. So something you might want to know, like what happened yesterday with rainfall in my whole area. So just like we've been doing for the rest of the things, I'm loading in a data set. I'm choosing which thing I want here. This is my calibrated precipitation. And in this case, I'm just getting data for the last month. So from the beginning of February to March, so just the last couple weeks. The only extra thing I'm adding here is I'm putting a little mask. So I'm getting rid of all the data that's less than 0.5 millimeters per hour, because that's about what the detection limit is for GPM. So I'm throwing out most of the low quality data. You don't have to do this, but it's maybe nice to get a more consistent average. I'm using the same things that I've been using all the afternoon to create my rainfall time series. And then I'm also going to create a rainfall sum. And I'm going to call this my GPM February rainfall sum. And if we look at how long this takes to run, this is also something that's going to go quite quick. Let's see. It's going to take a little bit longer because it's 3 hourly data, but it's still, okay, only 1 extra second, so 11 seconds. So this is something that can run quite quickly. And since it's already linked to my Google Drive, I can basically just run this instantly and get this rainfall map. So this is the last month of rainfall, or the last, I guess, 3 weeks of rainfall for Trishuli. So I don't know if you guys have seen this when you're up in Trishuli, if this is accurate. Has it rained this much? It's not very much, right? This is only 5 millimeters, so it's a very low rainfall. But this is something that you can choose any date range you want, right? So if I change this a little bit and say I want from January until March and run this all in one piece, it's going to export this, and it's just going to wait until my data is downloaded, and it will then create my image. And it should still only take 30 seconds for me to create a new image for a new time span. And then this is what we get for January and February. Yeah, so that was all I wanted to show you guys with how to make these consistent reports. On the GitHub, I have one further thing if you really want to dig into this and actually start using it. I exported this, this last little piece of code and all of the other parts that led to it into one file. So you could just run this file as its own Python file. But since we haven't really talked about running individual Python files, I'm not going to dig into this too much. But if you are interested in running this not as a one point at a time, but just run the whole thing through to set it up to run once every week or once every month, then the code to do that is on GitHub. It's called generatefiguretrishuli.py. And if you run that, it will just make that image for you. It'll download the data and do it. Yeah, so that's the short and sweet what I wanted to show you about what's possible, not just for making this kind of consistent time series, but also for making maps and this kind of combined figure. Questions, comments?